Good morning, everyone. I hate to be the people that are standing between you and your lunch, but I guess we'll just have to deal with that. So today we're going to be talking about how the Revit API helped design a super hospital. So who are we? This is, again, Colin Stark, already introduced.
Yeah, I founded Stark BIM about a year and a half ago. We do BIM software development, including custom development services and consulting. But this project is about while I was still an employee at HH Angus, where Akira is currently an employee. I do have a booth over in the other room, so come stop by if you have any questions after.
And as Colin said, my name is Akira Jones, and I'm a project engineer and the BIM manager at HH Angus. I guess this is not, we didn't get the, I was just going to briefly do an agenda. I think this was updated, but I'm just going to briefly talk about the project itself and how it introduced us to the API. Colin's going to talk to you about the API at HH Angus. Then we're going to kind of talk about how it directly helped the project and then go over kind of how we see the future. So the super hospital, Centre Hospitalier de l'Université de Montréal, or CHUM, as I will refer to it from now on, because that's a bit of a mouthful. It's a 3.8 million square foot facility when complete. 5 buildings over 2.5 city blocks, 775 single patient rooms, 39 ORs, 7 MRIs. This is a massive, massive facility. The project contained over 60 Revit MEP models alone, and phase 1 design work spanned from 2010 to 2016, and phase 2 design is actually currently underway. And I'd like to point out that the facility is now open to the public, and they're going to be starting to transfer patients
this week, right?
Yeah, this week from the adjacent St. Luke Hospital. So big things happening there. Now I just want to point out that Revit use was mandated on this particular project, and it was actually only HH Angus's second Revit project ever. So yeah. So this is just a snapshot of some of the MEP systems in the project. This shows about 5 floors of the main clinical areas as well as an adjacent support building. This represents less than 20% of the overall project. So it's just to give you an idea of the complexity of the project we were dealing with. I think at the time it was the largest single build in North America, and we think it was the largest Revit project as well, but that should be confirmed. So as you can imagine, there was a lot of challenges with this project. I think one of the biggest challenges was the number of models and the elements and the data contained within these models. As an example, we had over 10,000 terminal boxes alone, and each one of these was individually scheduled. We also had a lot of issues because because we had so many models, it was difficult to transfer data between these models effectively, and it was also very difficult to transfer data out of these models in a consistent way. The change in requirements as the design progressed was also an issue, making sure that we maintain the integrity of our data as we went along. And I think one of the big internal issues that we had was inconsistent model setup. So when Colin and I joined the project, a lot of inconsistencies had developed within the models. This was anywhere from view templates to MEP Systems to how content was named and how data was stored. And I think this was a result of a lot of poor modeling practices. As well, the scale of the project made QA/QC on data a very challenging task. Doing any kind of data checking or data validation on such a large amount of data was very time-consuming. And Revit itself was a limitation on the project. I mean, when we started, it was working in Revit 2012, and then as time went on, we were able to upgrade to Revit 2015, and now today we're actually working in Revit 2017. So it's a good thing. So good practices, or the lack thereof. I think that, sorry, I'm just lost here. Now, it may seem obvious to everybody in the room here today, but implementing, or having some level of modern standardization was really essential to being able to deliver this project, over the long term. And one of the first things that Colin and I undertook when we started on the project was to bring a new level of model standardization to the project, and this included updating, content and model visualizations, as well as bringing some standardization to the data itself. But I think the biggest challenge with this was kind of communicating the requirement for consistency to the users and our modelers. At the peak of the project, we had about 50 people working in the Revit models, many of whom this was their first Revit project, and a lot of people who were coming over from the AutoCAD world. So you can imagine there was a lot of issues with bad habits, and it took a lot of time and patience and a lot of undone and redone work to kind of really instill these good modeling practices in our users. It was kind of during this time that Colin and I were, bringing up the standards and the models and trying to train the users with good modeling practices that we started to see the potential for the API. So as Colin and I spent a lot of time updating data and updating the standards in our over 60 models, we started to realize that a lot of these processes could be partially or fully automated by using the API, thus kind of freeing up our time to do more important things. And I think what we didn't realize at the time, but this model standardization became, vital for being able to leverage the API in a more powerful way down the road when we started developing productivity tools, as well as the data mining that became really essential to the project delivery. So at this point, Colin's going to kind of talk to you a little bit about the API itself at HH Angus.
So here, just a little example of one of the tools we wrote. This is a model opener. I'll get more into the tools themselves later. I'll give you a little overview of the API itself first. So API stands for Application Programming Interface. An API is effectively something that allows a program to control another program, as opposed to using a mouse and keyboard that you would normally use to control the program yourself. For the Revit API, only functions that Autodesk has permitted can be used, and it's officially supported by them. An example you probably all know is Dynamo, which is essentially a visual front end on the Revit API, allowing people that don't know how to code to take advantage of the API. And any macros or third-party tools that you use are also leveraging the Revit API. So the first issue for us was to identify which tasks were suitable for automation. Resources are obviously limited, so we couldn't automate everything in the whole project. That would have been nice, but it would have put everyone out of a job also. So we identified 3 areas where we could start to automate tools or automate tasks. The first was the most time-consuming tasks, in particular tasks where there was a lot of downtime for users, so they would have to click something and then wait for another thing, and then click again and then wait for another thing. We really wanted to eliminate that dead time for users. The next area that we focused on was error-prone tasks, the best example of which is reviewing data and data validation. People just don't do a very good job at reviewing huge lists of numbers and similar looking words and things like that. We found that the error rate was generally about kind of 5% when people have to review big sets of similar looking data. And on a normal project that might be acceptable, but on a project this big, 5% of terminal boxes being wrong is 500, which is more than you have on a standard project, so that was an unacceptable amount of error for us. And the last area that we focused on for developing tools was just when it was very easy to do so. For example, simple tools that might have only taken 10 or 15 lines of code to write, that only takes about 30 minutes from start to finish, including testing it. Even if it's only saving 1 or 2 seconds each time a user uses the tool, those 1 or 2 seconds add up very, very quickly to make the 30-minute investment in creating that tool worth it. And of course, talking about this project, the benefits are even greater because the scale was so big. So I'll give a little introduction just on some of the things that we did at HH Angus for some of the tools that helped us out. What you can see here is the menu bar that users have in all instances of Revit at HH Angus. There's an additional section to it for administrators that we couldn't quite fit on the slide. So there's a few categories, again, that the tools kind of fall into. The first is data validation. The best example of this that we use on a regular basis was just a simple tool to compare the sum of the flows of VAV boxes to the diffusers that are served by those boxes, making sure that the systems are well balanced. It's just a simple tab, tab, tab select in Revit. You get the flow of the VAV, you get the flow of the diffusers, and you just make sure that they match. Another tool that we'll talk about a little more later in the presentation is how we use the API to size all of the reheat coils for those 10,000 boxes on the project. The next area that we focused the tools on was overcoming Revit bugs and shortcomings. So we had a few strange issues that popped up throughout the project. We found often that our flows on our diffusers or on our VAV boxes were getting reset to 0. We think Revit was trying to calculate the values and things weren't set up properly, so it decided that the flow in the system was 0. And we used the tool I just mentioned to make sure that we didn't have any of those 0 flow boxes or diffusers still remaining in the project. And we also had a strange issue back in 2012, 2013 with keynotes in linked files, where when someone would keynote an element in a linked file, these strange ownership errors would start to propagate throughout the project. So we wrote an API tool that prevented users from being able to keynote elements in linked files, and instead we implemented a system where you placed a dummy element that would hide itself once a user placed the keynote onto it. The next tool, and this was the main one that we used at HHA, I'll talk a little bit more about it shortly, is batch printing and export utility for sheets, printing to PDF and exporting to DWG. We also made some tools that increased accountability for users. So the first of which is the Who Drew It tool. That was just a simple utility in the vein of the very easy to create tasks that I talked about in the previous slide that just showed who created the element and who last edited it, bringing that work sharing tooltip information, just making it a lot more accessible to users in a single click. We also implemented an action monitoring sort of audit log trail that logged every action performed and saved it into an external database. And that helped increase accountability for users and improved the quality of our files. And like I've referred to, we also just focused on making standard features a little more accessible and added some convenience tools like selection tools that allowed us to do things like easily select all of the tags of an element or select the host of an element by clicking on its tag, selecting all instances of a family in a view instead of just selecting all instances of a type. Just little time-saving things like that really added up over the course of the project to make Revit a lot easier to use for our staff. So key to many of the tools was an external database that we had. This wasn't a full copy of the data in Revit. It was just limited information that we stored outside of Revit to make more easily accessible. It was automatically updated every time the model was synchronized to Central. That way we never had any invalid data in the model or in the database. Say if a user was working locally and did some work but then quit without synchronizing, that data would never make it into the database. And because it was automatic, we never had an issue where the data in the database was out of sync with the data in the models. Not a viable solution for syncing the full content of the Revit file. It would take too long, but for the limited information we saved in the database, it was a good solution. And the batch plotter that I mentioned, this was key to using that tool because we saved a list of the sheets outside of Revit, and that allowed us to pre-select the sheets that were spread across our 60 Revit models, pre-select all of those sheets, and then the tool would take care of opening the models, printing the drawings, naming them correctly, close the file, and move on to the next one. And we had some remote workstations set up where people could run the jobs on those remote workstations so they could continue doing work on their own machines while the lengthy printing process ran. And like we had files on this project that would take 25, 30 minutes to open because there'd be 20 links in them. So this really, really saved a lot of time. This also allowed us to do a lot of analysis outside of Revit. We were able to export equipment data. We didn't store the data itself in the database, but we used the database to store all the types of equipment that you can see here, and it allowed users to quickly select the types of data they wanted exported, and it would export everything from the whole model into Excel very easily. And finally, the action monitoring audit log that I referred to, that was all stored in the database. What we didn't tell our users is that the data was actually completely incomprehensible and we couldn't make any sense of it, but just the fear of them thinking that we could see everything they were doing made the quality of our drawings go up dramatically overnight on the first day that we told users that we were tracking everything. So a little bit of fear is clearly healthy to keep people doing their jobs. So I made a little word map of the most commonly used tools that we had at HH Angus. The larger the text, the more commonly used the tool was. You can see a few really jump out. So we started tracking data in April 2015. The tools have been around longer than that. But since then, the Who Drew It tool that I talked about has been used 17,500 times, roughly. And the batch plotter that I talked about has, if you put all of the usages end to end, it would have run for 315 consecutive days. So about 40% of the total time that has elapsed since April 2015. Oh, sorry. That's about 7,600 hours for people that probably couldn't do the math in the head like myself. And you can see a few other tools that were commonly used. We also had a bunch that were kind of single usage tools that didn't make it onto the word map because they were only used a few times for a single very complex task.
So, as Colin has told you, there's, the API was used to create a lot of tools, and a lot of processes came out of this that, obviously saved us a lot of time. But, how did this directly help the project? So I think number one is that, as Colin mentioned, is the staggering amount of time that we were able to save, both for ourselves and for, the designers working in the Revit model. With the combination of remote workstations and the productivity tools, we were really able to keep people, working on things and keeping them billable, and not just waiting for their workstation to perform a task. I think one of the other things that was really important was that we were able to make a more user-friendly and a more effective way of using Revit for what it could already do. We made Revit easier for people to use, and this was really, really important at the time because, as I had mentioned, we had a lot of people who were using Revit for the first time, and a lot of AutoCAD users migrating over to Revit. So anything that we could do to make Revit easier to use for them was extremely valuable to us. We were also able to use data mined from the database to perform some basic analytics to help us improve our own internal workflows. I think one of the small examples is that Colin and I had noticed that the team was spending a lot more time synchronizing to the central model than they should be. They were synchronizing more often than what we had recommended to them. And anecdotally, we knew that this was probably chewing up a lot of time based on the size of the project team. So we mined the data from the database and looked at how much time was spent over 3 months, just synchronizing to the central model. And once we were able to present that information and the amount of basically days and hours and the amount of money that was spent synchronizing the central, it really made it gave a tangible reason for the users to actually follow our advice in terms of when they should be synchronizing to the model, which I think is always very useful. And I think we were also, we were able to, improve the quality of our data, which was very, very important considering, being able to manage data as the design changed. I think those were, some of the key points of how all these tools, helped us on this project.
Yeah, so the best example of how we used the API to help us with managing the data was for sizing those 10,000 coils that I mentioned earlier. And what we needed to do was tie the room data, where we knew what the specs for that room were supposed to be, with the terminal box. But you can't do that very easily because the boxes were always located outside of the room. So we used the API to get all of the rooms associated with diffusers, and then we traced back through the ductwork to link each terminal box with each room, and that way we were able to export the data into our sizing application that allowed us to quickly and automatically size all of the coils for those boxes. It would have been a pretty, like, it would have probably, I think we worked out it would have taken 3 engineers 3 weeks every time we had to run through that process, and we were able to cut it down to a matter of hours using these tools.
Right. And I should mention that, at this point, understanding the updates in Revit, on this particular project, we didn't use MEP Spaces, and I believe at the time, the way the Spaces worked with 2012 wouldn't have been able to allow us to do this anyways. And we understand that, Revit these days has the capability to do some of the things that we were programmed. But at the time, we were using the API to overcome some of the limitations that had existed. I went backwards. Green button. Green is go. So the amazing thing about this was that once we had spent the time on the programming, we were able to, we had the ability to repeat a lot of these processes over and over again. All the time that was spent inputted into the programming time was more than made up for the fact that on these massive exercises of data manipulation, we were able to repeat these processes very quickly and also very reliably. And this, again, freed up a lot of our time to be working on other things. And a great example of this again is the the reheat coil sizing that Colin had talked about before. And the best part about this for us was that all these tools we have been using on all of our future Revit projects. So again, all this time investment has more than been made up for by the fact that we've been able to save so much time on every future Revit project that we worked on. So in terms of the future of building design, I mean, based on where we see the industry today and what we see out there in terms of productivity tools, a lot of the things that we learned on SHROOM we feel are a very much important part of the future of building design. And I think first and foremost is the effective mining of data from our models. Once you've mined that data, you can move it into doing calculations outside of Revit using your own proprietary softwares that you developed, or taking that data and using it in other BIM softwares, and bringing this data back into your Revit models. I think you can also use it to do validation on your designs and your data, again, outside or inside the Revit model. But I think the important part that we really want to point out here is that the API can be used to partially or fully automate all of these processes. I mean, you can automate the process of extracting the data, automate the process of moving the data around, and we feel that you'll soon be able to automate the process of using that data and completing your designs within the Revit model. This is kind of where we see this going, and obviously this will make our work more efficient and more reliable, which I think is a good thing. Something that all of us really want.
Yeah, and a key point to note about the mining of the data is that sometimes you just mine the data for the sake of mining it because you don't know down the road what you might find uses for it. A lot of the data we had in our database at HH Angus, we might not have touched for a year or two even until we finally said, oh hey, we've been tracking this all along, we can find out all of this information. Stuff like the command data that we pulled out for this presentation. We hadn't even really ever looked at that data since we started tracking it, but you never know what you might find a use for down the road. And what we see really starting to happen as software gets more and more complex is just more and more of the design process being automated once kind of natural language processing evolves to the point that software can understand the building code, for example. You can start to perform, be able to start to perform automated validation checks on your models to make sure that they correspond with whatever codes and the jurisdictions that you're working in. And yeah, there's anything else?
No, that's it.
Yeah, so does anyone, I know you guys are all hungry, so we'll keep it short, but does anyone have any questions?
I do. Impressive, and congratulations, and thank you for your presentation. A couple of quick things. For me, it's important as an owner how you came about to find yourselves in this situation. Like, who really empowered you to take on this task, to manage all this? That's my first question. And second is, how did all this rub off on the other disciplines, electrical, architectural, structural, civil, etc.? Because right now, you've talked primarily about MEP, but I'm curious about the whole integrated process. Thank you.
So HHang is an MEP firm only. There's no other disciplines, so we didn't really have any rub-off onto any other disciplines, although I would say that probably 60 or 70% of the tools we wrote, there's no reason that you couldn't use them in another discipline, like things like the batch plotter and all of the user accountability, things like that. There's nothing mechanically or electrically specific about those tools. We did focus mostly on mechanical stuff in our talk, just because that's our background. It's what we know. And to answer your question about how we kind of started doing this in the first place, I am a mechanical engineer originally by training, but I've always known how to program and done it on the side, and I looked at some of the tasks that I was doing, and just a kind of a bell ringing in my head saying there's probably a better way to do this. And because the project was so large, there was enough overhead that to support me just working full-time doing software development on this project. If it had been a smaller project, there might not have been an opportunity because the project budget wouldn't have allowed for it, but because this project was such a monster, there was enough overhead in the project budget to allow me to work full-time developing software for the project.
I would add to that, I think that Colin and I were very fortunate in that, we had a couple of superiors who were very forward-thinking, and they saw the value in the work that was being done and the value of, how it would affect us. Obviously Revit as a design tool isn't going to go anywhere. So, this time spent wasn't in vain, and it wasn't, it would help us beyond the Shroom project. So I think, we should just really make that point that, we were able to kind of spend this time because, our superiors saw value in it outside of the project as well.
Mm-hmm.
Any other questions? Okay, thank you, gentlemen.